Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Natasha binti Muhammad Zamri, matric number 264436. This project is about the application of conics in engineering and architecture. Now I will talk about the solving applied problem involving hyperbola in the context of cooling tower. Cooling tower is applied in architecture field. Cooling tower is a heat rejection system that rejects waste heat to the surrounding through the cooling of a water stream to a lower temperature. It is used the evaporation of water to dispose of process warmness and cool the working fluid to close to the wet bulk at temperature. The design layout of a cooling tower is shown in figure. The tower stands 179.6 meters tall. The diameter of the top is 72 meters. At their colossus, the side of the tower is 60 meters apart. The aim of the problem for this application is to find the equation of the hyperbola that models the slide of the cooling tower, and assume that the center of the hyperbola, indicated by the intersection of dashed perpendicular lines in the figure, is the origin of the coordinate plane.
I am Nur Fazlin binti Halim, matric number 264496. So, for the solution, we use standard form of a horizontal hyperbola centered at the origin, which is x square over a square minus y square over b square equal to 1. First, we need to find the value of a square. So, 2a equal to 60 meters, a equal to 30, a square equal to 900. To solve for the b square, we need to substitute for x and y in our equation using a known point. To do this, we can use the dimension of the tower to find some point x, y that lies on the hyperbola. We will use the top right corner of the tower to represent that point. Since the y-axis bisects the tower, our x value is represented by the radius of the top, or 36 meters. The y value is represented by the distance from the origin to the top, which is given as 79.6 meters. So x equal to 36 meters, y equal to 79.6 meters. Then substitute the value of x and y into the hyperbola equation, and we get b equal to approximately 14400.333. The side of the tower can be modeled by the hyperbola equation. X square over 900 minus y square over b value equal to 1, or x square over 30 square minus y square over 120.0015 square equal to 1.
Assalamualaikum. My name is Nosira binti Saidi, number matrix 264567. I am going to explain about the application of non-circular gears, which is elliptical gear. First, the equation of the ellipse in Cartesian coordinate relative to its geometric center is two equation, which is xp equal to a cos theta. Second is yp b cos theta. Yp b and yp b cos theta, which is a is the ellipse semi-major axis, and the b is the ellipse for semi-minor axis, and which theta is the angle of rotation. First, before creating a designing this elliptical gear, it needs to generate the evaluate of the ellipse, which represent the center of rotations of the series of the circular arc of the pitch curve of the elliptical gear. And the equation is following by xe equal to it has two equations. First is xe equal to b squared minus a squared per a multiply with cos theta cube. The second is ye equal to b squared minus a squared per b multiply with sin theta cube.
For the first step is to generate the pitch curve in addition to the tip
rod, and base curve of the gear. The base curve represents the evolved teeth profile of the elliptical gear, which can be obtained by the equation in Cartesian coordinate. And the equation for xb equal to xp minus xe cos guardian ratio plus xe, and for yb equal to yp minus ye multiplied by cos guardian ratio plus ye, where xp yp is represent for the coordinate of the pitch curve and xb yb is represent for the coordinate of the base curve, and for the guardian ratio is for the standard pressure angle of the teeth. The tip and root curve are not ellipse, taking into consideration that these curves are a series of circular or circular gear which their center are the equivalent of the pitch curve and can be obtained by the equation xt equal to p plus m divided by p and multiplied by xp minus xe plus xe, and yt equal to p plus m divided by p multiplied by yp minus ye plus ye, and for sr equal to p minus 1.25 m divided by p multiplied by sp minus se plus se, and lastly yr equal to p minus 1.25 meter divided by p multiplied by yp minus ye plus ye. Many other type of non-circular gear can give the same result, but the elliptical types are simpler. They can be made extreme pair and their contour can be approximated by a series of circular. And the equation is P equal to xp minus xe power of 2 plus yp minus ye power of 2 square root of 2. So as known, there is no accurate formula for calculating the circumference of the ellipse. All the equations are approximate error about 1% at least of the circumference. So we create a function in MATLAB for calculating the circumference of the ellipse accurately. Error less than 0.0001 mm equal to 0.1 mm. Now the number of teeth can be obtained from S equal to PC multiplied by Z. So where S represent the circumference of the pitch curve and Z represent for the number of teeth of the elliptical gear, which must be integer number. So this is the figure 5, elliptical gear main curve. Figure 5 show the pitch curve, value of the pitch curve, base curve, value of the teeth profile, root curve and tip curve of the second order elliptical gear for the input. A equal to 52 mm, B equal to 36 mm, and M equal to 3 mm, and for the guardian ratio equal to 20. It's been designed in MATLAB. So, for the last of first step is the eccentricity of the pitch curve. Ellipse is height E equal to square root 1 minus B divided by A power of 2 equal to 0.72. When the eccentricity is low enough, there will be no intersecting between the base and root curve. Knowing that this intersecting has no effect on the teeth profile generated.
I am going to explain about how to generate the teeth of the pitch curve on the elliptical gear. The equation is PC equal to pi multiplied with m. This function has the basic input with rho, m's, pi, and others, and it gives the tooth and the coordinate of the tooth profile as the outputs for the purpose of generating text file of the coordinate to be used in generating a 3D elliptical gear in SolidWorks mechanical design program. This figure shows the output of the created function for the input rho equal to 47 mm, m equal to 3 millimeters and pi equal to 2 degree. Combining all the previous MATLAB function and scripts together give a full software code to generate a second order elliptical gear. Next is the eccentricity of the pitch curve that ellipse with the number we have b equal to a equal to 52 millimeters and b equal to 36 millimeter. We can calculate the eccentricity, which is equals 0.72, and the eccentricity is low enough. There will be no intersecting between the base and the roots curve, knowing that this intersecting has no effect on the teeth profile generating. That's all from me. Thank you.